We know it's a powdery surface at the very top because it's been smashed up by impacts. But it's a very complex surface at the same time because impacts have mixed and tossed things around and smashed things up. We do know something about how the composition varies around the moon, but there are some places we know nothing about. There are dark areas at the poles that are permanently shadowed from the sun and very cold. We don't know anything about those areas. We presume the material properties are similar, but if there's ice there, it might be completely different physical properties. And so we just don't know anything about that. So there's an area of the moon, I don't know what percent it is, perhaps 1% of the surface, completely unexplored. If there's water on the moon in the form of H2O, already in the form of H2O, it is in those dark areas at the poles. The evidence we have to date indicates that there might be an enrichment, but what we see the enrichment in is only hydrogen. We have ambiguous evidence that is quite hotly contested about the presence of ice. What's interesting about these areas, though, is that the fact is you have to go and measure it in situ and find out how much H2O is there really. And the beauty of this actually is a beautiful example of where science and resource exploration go hand in hand. Whether there's a resource or not, there certainly is enough H2O, or even just hydrogen, to be scientifically interesting. It may be well below the threshold of 1 or a few percent that would be useful for making propellant, but it is not below the threshold to be scientifically useful. And so we can understand what is the source of those things. Is it comets? Is it some kind of wet asteroid? Is it even materials from dark molecular clouds that people have talked about? Interstellar materials that are accumulating in places like this. And so you find out about that, the delivery mechanisms to the poles, the processes that could take place at various cold temperatures. Is the natural laboratory for studying these things. Scientifically, you can't lose. Maybe you don't get the resource, maybe you do, but by looking for the resource, we do the science at the same time. The first step of finding out, is there any significant deposits there, really is a robotic problem, because it's not easy to send people to these extremely harsh environments, and I think we can solve the problem robotically. Others, geologic fieldwork, to do some of the very important scientific things that bear on the history of the solar system, the history of the Earth, those require people doing geologic fieldwork. So, it's going to do both of them, and I think we're all on the track. And the trick is not to be too impatient. We're not going to, the continental U.S. was not settled very fast. There was a whole group of people here when Europeans arrived, and they had not settled everywhere. They did not have a big thriving economy yet, and so it takes a long time. But what we have to do is to start it out right now. The NASA program is being very welcoming to corporate involvement. The corporations, though, they do want to make money, so they have to see that something is real. So I think the government needs to do enough so that it is clear that there's going to be a true viable future before companies start to invest in anything. And it depends on what the resources are. Are they going to be used just in space, which is at first certainly most likely, or is there something to export to the Earth? Is it a matter of that the environment on the moon allows certain manufacturing techniques? Truth is, we don't know any of that. Everybody who works in this game, including me, has their favorite kind of resource, but it may turn out to be something completely different that we just simply don't know. The most common idea is that we can get propellant, hydrogen and oxygen. There is plenty of hydrogen actually on the moon in the form of solar wind implantation all over the moon. We know where it's richer and where it's poorer, besides just ignoring the lunar poles. Right. But it's a matter of energy. You can extract from the lunar dirt, it's by volume, half is oxygen. Okay. It's only a matter of reducing it out somehow. And how you do that is there's 22 techniques have been proposed, some of which have been tested with very solid experiments, some of which are adaptations of things we already do, like the methods used. There are electrolysis methods to extract aluminum from bauxite, and that can be applied to the lunar soils too, to extract metals, and a byproduct is oxygen. Right. So it's there. What we need is to do more experiments on small scale to show feasibility, and then to use on bigger scale experiments and maybe pilot plants to land on the moon to show that it really can be done. And there's something we're not putting enough effort into, it's that. We really need to try it, to show it, to do the engineering models. Because I think scientifically we understand what can be done, but you know how much power is required. Is it too much? And how do we really get it done? Well, these are engineering issues, and we really need to push them. Though maybe the fundamental thing is to make sure we all commit in space programs to settle the moon. And that's what we are trying to do. Because if you're not going to settle it, you're just going to go and visit and say, oh, now we know how to do this again. Let's go send a crew to Mars who will do the same thing and then abandon it like we did the moon after Apollo. We won't get anything out of it. There won't be an infrastructure left. And that's what many of us who want to go to the moon first and really learn how to do it before going to Mars, even if we want to go to Mars with people and more robots too, I think that's the key thing, is that we want to really get it, to get something permanent and to expand human presence. And I think it will benefit all of us here on the Earth. There will be there's new wealth created. It could end up in the hands of a few, but if we do this right, and it is for everybody, and other nations and companies and other nations are involved, it will be shared wealth.